Okay, chapter 8 on cognition and language. So this chapter has three different modules and it's broken up in three different ways. So module 23 will be talking about thinking and cognition, everything that goes along with those two subjects, which we'll talk about in that module. Module 24 deals with problem solving, and then module 25 deals with language. So it's broken up into three different areas with three different modules that go along with it. So let's start out with module 23, thinking and reasoning. And there are two different questions that we're going to answer in this module. The first one is, what is thinking, right? It would be easy, once again, as I keep saying with various topics, to think about what is thinking, right? It's hard not to use the term thinking when you're trying to discuss what thinking is. The second question is, what processes underlie reasoning and decision making? Those two parts, reasoning and decision making, are a very big part of thinking overall and cognition. So those are the two questions that we are going to answer in this module. So let's start out with cognitive psychology. This is one of the subdisciplines, one of the 25 or 26 different subdisciplines that we have in psychology. And so let's just do a basic definition for what cognitive psychology entails. So it is a branch of psychology, like I said, a subdiscipline that focuses on the study of higher mental processes. So some of the various things that are included in cognitive psychology. One is thinking, also language, memory, problem solving, knowing, reasoning, judging, and decision making. So you can see there's a lot that falls under this cognitive psychology. And each of these are very heavily researched in the field of psychology. We're going to start off with thinking behavior, what that actually means. So when we look at other species besides humans, so other non-animal species or non-human animals that we have, there is no other species that is involved as humans whenever it comes to thinking. So there's no other species that contemplates, analyzes, collects, or plans the way that humans do. We will discuss some other animals that go into, there are other animals that may analyze problems. They may plan, their next behavior, so on and so forth. But they don't do it to the extent or the detail that humans do. Whenever it comes to a basic definition, I said that that first question in this module is, what is thinking? When we talk about thinking, it is an actual brain activity. You can't actually see someone think, but you can see the outcome of that thinking. So it is a brain activity where people mentally manipulate information, which includes words, information coming into your eyes, so the visual images, information coming into your ears, so auditory information, and then other data also. That is all encompassed under thinking. So let's focus on mental imaging, examining the mind's eye. So when some stimulus hits your eyes, we said that the information then travels through your eye. It goes up to the visual association area in your brain, and you recognize what that stimulus is. And then you go about behaving according to that stimulus. But you have this mental image in your head about what you're seeing. So it is a representation in the mind of an object or an event. Every sensory modality produces a corresponding mental image. So sensory modality, if it's vision, if it's hearing, if it's touch, if it's taste, if it's smell, each one of those has its own corresponding mental image. You have an image in your brain of what you are seeing, of what you are smelling, of what you are touching, so on and so forth. These mental images have properties of the actual stimuli that they represent. So you have a mental image for a strawberry, right? That has its own mental image of that actual stimulus. You have a mental image of sandpaper. So that is not only what sandpaper looks like, but also how sandpaper feels. You have a mental image of chocolate cake. This is a mental image of what chocolate cake looks like. You have a mental image of what chocolate cake smells like. You have a mental image of what chocolate cake tastes like. And then if there's any emotional significance to that also. The production of mental images actually improves various skills. So an example of this is athletic training. And they give you an example in your book that goes along with that. I'm trying to see. It says, for example, piano players who simply mentally rehearse an exercise show brain activity that's virtually identical to that of the people who actually practice the exercise manually. So if you are an athlete and you play basketball or you play football or you play softball or soccer or whatever it is, you may practice those various skills in your mind. And what is activated in your brain is the same as though you were actually carrying out that activity. This example is figure 1, and this is at the top of page 237 in your book. And so you have A, B, and C, right? And it tells you that it wants you to mentally in your head rotate one of each pair of patterns to see if it is the same as the other member of that pair. And it's likely that the farther you have to mentally rotate a pattern, the longer it will take to decide if the patterns match each other. So you can see, right, in letter A, could you switch that mentally in your head, rotate that to see if it works the same? So you can see that A on the left-hand side is very similar to the third object on the right-hand side with that. The same with B and then with C, but you have to do some sort of mental rotation in your head because you do not physically have it in your hands. I'm asking you to mentally rotate it. And so the more that you have to do, the harder this is going to be and the longer that it's actually going to take. But you have to have a mental image in your head on how to do that. We also have concepts, and concepts are used as a way to categorize the world in which we live. So a concept is a grouping, a mental grouping of similar objects, events, or people. So it could be fruit, right? Fruit is a concept, and you could mentally group various fruits, apples, oranges, strawberries, pears. It could be events. You could be thinking of outside athletic events, football, baseball, cross country, right? So your concept and then what those various similar objects are, but you have to mentally think about it. Concepts actually enable us to organize complex phenomena into various categories. And therefore, by doing that, it makes it easier to understand and therefore remember. If we have a whole group of different objects, can we categorize them into different concepts? And if we can, then that will make it easier for us to remember all those different things in the list. We also have what are called prototypes. Prototypes are typically highly representative examples of a concept. This figure is at the top of page 239, and it's going to, in the first column, of course, give you the prototype ranking from most typical to least typical, right? Furniture, and then vehicle, weapon, and vegetable. So a highly typical prototype of the concept furniture is a chair, whereas a stove is not a good prototype. And this is it says it's high agreement exists within a culture about which examples of a concept are prototypes, right? So for a prototype, the most common for vehicle is car. The least typical is sled. Now, if you lived in an area where there was a lot of snow and cars were not the typical means of transportation, then sleds might be much higher than that. But you see how you have these prototype rankings for that. To give you an example between the concept and in the prototype that you have for those. So we talked about thinking, we talked about concepts, right? We talked about mental images. The next thing that I want to talk about is reasoning, making up your mind. And we have two different types of reasoning. We have deductive reasoning and we have inductive reasoning. Deductive reasoning is the reasoning from the general to the more specific. Inductive is the opposite. It is the specific to the more general. So we have two different types of reasoning that fall into that. So if you were deductive reasoning, you would think of fruits and then go down to very specific fruits. Inductive reasoning would be where if you think of an apple and then you would go to the more general of fruits. Okay, so deductive is general to specific and inductive is specific to general types of reasoning that you have along with that. Now, let's talk a little bit more about reasoning. And we've had this fall under this title of making up your mind. The first type of reasoning we have is called an algorithm. An algorithm is a rule that guarantees a solution to a problem. So your example would be a squared plus b squared plus c squared, right? If you do that correctly, or if you apply it correctly, then you should get the correct answer every single time, right? So there's certain algorithms to figure out various problems. We also have what are called heuristics. A heuristic is a thinking strategy that may lead to a solution, but it could also sometimes lead to errors. And we have three different types of heuristics to kind of explain this, how it could lead to a solution or it could lead to an error. An availability heuristic is the first type. This judges the probability of an event occurring on the basis of how easy it is to think of examples. So you come up with what is most readily available to you for the availability heuristic. So the book gives you different examples. Let's say on page 240, it says, The availability heuristic makes us more afraid of dying in a plane crash than in an auto accident, despite statistics showing that airplane travel is much safer than it is to actually travel by car. Similarly, although 10 times as many people die from falling out of a bed than they do from getting struck by lightning, we're more afraid of being hit by lightning. The reason behind this is that plane crashes and lightning strikes receive far more publicity, and therefore they are more easily remembered, and so they're more easily available to us. So you can see, again, if you look at the definition of heuristic, it's a thinking strategy that may lead to a solution, but it can sometimes also lead to errors, right? So this would be an error. You're using what's more readily available to you, but it's not always true. We also have what's called the familiarity heuristic. The familiarity heuristic is where you choose familiar items to be seen as superior to those that are unfamiliar. And it says, so often what we go with seems most familiar. On the other hand, it's not so good if you're an emergency room physician susceptible to the familiarity heuristic. If you simply settle on the first, most obvious diagnosis for a patient, you may miss making a more accurate diagnosis. So each person is individual, and you shouldn't just come with what's most familiar to you. Sometimes you need to delve a little bit deeper so that you don't make an error in a diagnosis. The third one is what is called present bias. And this is the tendency to more heavily weigh options that are closer to the present than ones that are further away. So it says in the book, for example, suppose you were given the choice between receiving $150 today or $180 a month from now. If you're like most people, you're probably going to choose the $150 today. But that's actually a bad move. You're giving up a 20% return on your investment. So it gives another example, and it says, suppose the question you were faced with was to choose between taking $150 in 12 months versus $180 in 13 months. When it's put that way, most people will take the $180 because it's farther away to you. So you have to actually think beyond the present, right? But these are three heuristic errors that we make quite often in our lives. And as we go through these, you may have thought of situations where you have made these heuristic errors. The availability heuristic, the familiarity heuristic, and the present bias. All three of those should not be taken at face value. You have to think a little bit more in depth with each of those. The next thing to think about is computers and problem solving. And here we're talking about artificial intelligence. Artificial intelligence itself is this field that examines how we use technology to imitate human thinking, problem solving, and creative activities. It is very common in today's society to have computers with you, right? We have telephones, we have cell phones that we are constantly on, right? If we need to know how to get somewhere, we just automatically plug that into our cell phone and it will give us the directions on how to get there. But sometimes that's not always the best case scenario. So again, today, artificial intelligence uses machine learning. So it can process immense amounts of data and make probabilistic guesses. So computers using artificial intelligence are somewhat good at tasks that require speed, persistence, and a very huge memory. And two examples for those are when you use Apple Siri or when you use Alexa for that. So both of those are good examples where it would be much faster than you trying to actually go and figure out what it is. It will persist until it finds the right answer, and it has this very vast amount of memory. So artificial intelligence, there's good and bad to both of those. And you just have to, be wise enough, I guess, to understand that maybe this is good or maybe this is not good. But in today's world, we use them all the time. So good, bad, or the other, it is definitely the way of the future. It's not going to go backwards at this point. The last slide in this module is looking at video games. And can playing video games improve your thinking? It can, but it also then perhaps reduces your attention span. And so we have research looking at the effects of involvement in video games, and more broadly, technology is far from definitive. Gaming could sharpen or reduce your attention span. It could make you, be very detail oriented, depend on the game you're playing, but perhaps you are so detailed in that you cannot multitask. So therefore it reduces your attention span. After several studies that have been conducted looking at playing video games and thinking and attention span, more work needs to be done to draw a clear conclusion. We don't have a specific answer yet and whether or not it is good or bad. There needs to be a lot more research done in this area in order to come to a definitive answer on that.